Hello, my name is Roman Bui. Welcome to the second version of the video, so the long versions. We're going to be talking about the final project about big data case study in social media. Name of the project is Smile and Tweet. They use the smileys to train in sentiment analysis on tweets. So first of all, we're going to conduct a sentiment analysis, and here's some background vocabulary. Natural language processing is a field of computer science, artificial intelligence, and linguistics. And as you know, it's basically a bunch of algorithms that are used to process linguistic information. Most of the algorithms in NLP right now are based on machine learning. So in the case of a supervised machine learning algorithm, you need both a training set and a testing set. And today we're going to be interested into looking in more details the training set part. A sentiment analysis is really the idea to extract information from a text document. So you have this text approach. In our case, the text document is tweet lines. So we want to be able to classify into different labels those tweets. So here's the problem statement. So I'm going to start with the problem. You have more and more qualitative data, and they are more and more important in our world, even more due to the fact that you have different social media. I mean, Facebook came in, Twitter came in, and you have more and more data that is really written by human, and that is a type text. And you want to be able to treat that as a company or as an individual to know what is the trend or to have any idea of what's happening on this subject on the web. If you choose to go for a supervised learning machine process, you need to get a training set. And a training set is basically someone or some people labeling for you, so reading the tweets one by one and labeling them. So it's very costly and necessitates it really requires a huge human input. And that's one of the reasons why you have very important companies that has the resources to do so, that really have these algorithms working well. So Stanford came with an idea of using smileys to be able to automatically label tweets. And the idea behind this, we're going to go deeper into that, but it's really you identify several smileys as positive, several smileys as negative, and then you're going to automatically label the tweets. So once you've done that, you basically have a training sample. And our study is going to be how powerful can this training sample be? Is it enough in the context of a naive-based algorithm, for example, which is one of the most simple ones? And so what are we going to do? And that's the project description part, the first part. We're going to be using Mahout, implement a naive-based classification algorithm, and perform a sentiment analysis on tweets. And as a training set, we're going to be using the smileys provided by Stanford. So technology-wise, we're going to be using Mahout 0.9, Java 7.0, and the Cloudera virtual machine. I mean, as long as you have Mahout in Hadoop, you're good to go. Okay, let's talk about the training set because it's an important part of our study. You have all the sources in the report document. So the idea is to auto-classify based on the emoticons. So you take all the tweets, and if you see one of those emoticons here, those smileys, you consider the tweets as positive. Otherwise, you can consider it as negative. And everything that is not falling into these categories, you just delete them. Okay. Then you need to clean this classification. You need to clean all the smileys. Otherwise, when you're training your algorithm, it's going to just fit on these smileys because it's going to identify these smileys to be exactly the excellent predictors of the labels. So you want to delete them because you want the algorithm to focus on the bag of words. And so the final set is really a 1,600,000 tweets labeled as positive and negative. Okay, the algorithm. It's a naive-based algorithm, which you probably know of. The model is based on the Bayes theorem, which assumes strong independence. How to think about this is really you have those words, and let's say a word has an influence on the positive or negative label, and another one has an influence on the positive or negative labels. But these two influences are considered as independent. That's why you assume strong independency. So it's really the probability of a class given a tweet is the probability of a tweet given the class times the probability of a class divided by the probability of a tweet. You have to choose a distance schema, and you have to choose a weighting scheme. The distance is going to be the classical Euclidean distance. It's pretty classical to use that in sentiment analysis. And the weighting scheme is going to be TF-IDF, which is term frequency inverse document frequency. One of the ways to think about this is really you want to find the words that are really specific to a category and are very frequent within a category. And you want to find these words. So that's why it's term frequency, inverse document frequency. So very frequent in our category, very low frequency in the other ones. So that gives you words that are very specific to a category, basically. That's the way of remembering it. So the steps we're going to go through, and we're going to explain those steps in the next slides. First of all, you want to install Mahout, obviously. Then you want to get the data set. You want to prepare a working folder in the Hadoop file system. Sorry. Then you want to transform these text files into the sequence files. So now we don't have files that are organized into folders. We have CSV and text files. So we took this as an opportunity to dig deeper into Java classes and being able to create the sequence file from CSV/text files, and we think it's quite important because eventually you're gonna see these files in your future, and you don't want to know only how to treat the ones that are in folders, organized in folders. You need to know how to treat the one in CSV. So we're gonna show some Java classes that do that. Then you want to train the model, and then you want to test the model, and then at the end of these steps, you're gonna have an accuracy percentage, and we're going to discuss that a little bit, and we're going to see where the room for improvements and everything. Okay, step 1, you want to install Mahout. So to install Mahout, you have a sudo yum command. It's super straightforward. Sudo yum install Mahout. Then once this is installed, you have to change the different global variables. So you have to go into your bash profiles using the V editor. You have to change the Maven home, the Mahout home, the Hadoop home, Hadoop config directory. You might have some of them already depending on what is your configuration, but you have everything here. And then you have the path. You have to include in your path all those external variables, and you export the path. Mahout is very easy to install. You probably installed it already, but here is a quick recap of how you do it. Get the data set. So you can get the corpus data from Help Sentiment 140 for the students, and you want to take the training set that has 1,600,000 lines. For more details, you can always go into the Word document report. The testing sets, we decided to go in GitHub and find a corpus that belongs to Ravi Kiranj on GitHub. Obviously, in this case, you cannot have both a training set and a testing set that is coming from a big set, because you don't know if your training set is good or not. So you have to take the training set apart, which has been automatically created by Stanford using the smileys, and you're taking a testing set that has been manually filled by someone, whoever that is, and you want to test the strength by training your algorithm onto the training set that has been automatically done, and compare the model, apply it to a testing set that has been manually labeled, and so you can find the strength of your model, of your training set, in the context of the model. Then you have to create a local folder, what you're going to call final assignment without space. I made a mistake here, and you have to put the two files into this folder. Now, in Hadoop, you have to create the working directory. So very straightforward. It's just a one line: Hadoop fs -make directory mkdir final assignment. And in this directory, we're going to be working everything, so that's important you have it at the beginning. It's pretty straightforward. There's not much to say about this. Okay, we are at step 4, transforming the text files into the sequence files. So here you see that the text files has the following format. It's a sentiment, it's an ID, a date, a query if any, and then the tweet. As I said earlier, the files are not organized in label folders as usual, so you cannot use the usual Mahout command to get these folders and label it for you. You have to create a class in Java that is going to properly take these text files and transform it into a sequence file. Okay, one of the idea one could have, which is a very bad idea, would be to design a Python program or whatever program that would go through the files and create the folder architecture so that you can do the Mahout comments on the folders then. This is probably very costly because you're going to be creating a whole bunch of objects in Windows or in Mac or whatever. You're going to be creating a whole bunch of CSV, a whole bunch of folders. So it's probably not efficient in terms of performances. And the Java classes is not that hard to do. And we're going to go through it. And we think it's an excellent opportunity to understand the flexibility that you can have from this approach. So, starting on line 1, you have a public class, tweet2sec. So you just create a public class, and then in your main, as you can see, on line 8 and 9, you have 2 arguments that are going to be used. The first argument is really the input CSV file, and the second argument is the output sequence file. Now you create a configuration, you have a file system, etc. The important part are line 13, you have a writer, which is basically what is going to give you the opportunity to create a sequence file. And then you have a reader on line 16, which is the object that is going to go through your text file line by line. Now 17 and 18, you create local variables that you can call key and value that are going to take the key and value of each line in a temporary manner, and then you're going to fill the writer.